Hello, this video was made for the Basic Fluid Mechanics course in the Department of Civil and Environmental Engineering at the University of South Florida. Go Bulls!
Did you really have to say that, bro?
I kind of wanted to, okay? Wait, was that an alcohol bottle?
No, I'm pretty sure
What
it
does that
says no alcohol.
Not alcohol. Alright, as long as it's in there. Okay, everybody, let's dive into some fluids.
The buoyant force?
Was that a question? Let's first... Whoa. That was way too fast.
Alright, I'll work on it.
The buoyant force is equal...
I think I got it now.
Alright. The buoyant force, equal to the density of the fluid multiplied by its displaced volume, is what causes objects like boats
Or empty wine bottles.
or empty water bottles to float on water. The system we're looking at includes the volume of the water bottle and its insides. First, we saw it rise because it was full of air. The weight of the system is less than the weight of the displaced water, because air is much less dense than the surrounding environment. Therefore, the buoyant force pushes it up rapidly.
So why is this one floating upright?
Well, the weight of the system has some sand now. The weight of the air plus some sand roughly equals the weight of the water, thus causing the bottle's suspension.
Oh, so this one sank because there was more mass in the system, since the weight of the glass and the water in the bottle is greater than the water displaced by the bottle. The buoyant force wasn't enough to float the bottle.
Right. The gravitational force was stronger.
Alright, let's take a break.
Got any dihydrogen monoxide?
Nah, just got some CO2 mixed with some O2.
Oh, that's my go-to.
You should stop that.
Okay.
Fluid pressure?
Here, I've got a clear plastic cup full of air.
Cup full of what?
Air. Don't worry about where I got it. Anyway, this demo is basically buoyant force incarnate.
So bubbles?
Bubbles. The air inside rushes to the surface as soon as the cup is removed. Because fluids exert greater pressures at lower depths, we can't expect to see a perfect sphere here in a pool on Earth, especially in an uncontrolled pool like this one. However, because fluids do exert pressures in all directions, the bubbles will take semi-spherical forms.
What about these bubbles?
Who are you?
Don't worry about it, just tell me about these bubbles.
The reason we can see these bubbles at all is due to the surface tension of the water. That's like the way all the molecules of the water stick to each other. Even though the pool exerts pressure on all sides of the bubble, that pressure isn't enough to break the tension on its surface.
What if the bubbles are really deep?
Well, just like in an enclosed system, the air, or any gas trapped in a bubble for that matter,
Gas.
the gas will compress, so the bubble will be smaller. The higher external pressures compress the gas according to the ideal gas law shown here.
Check this out.
In this final demonstration, we're going to prove that the volume of this water bottle is greater than this plastic cup, if you couldn't already tell.
Water? You doing wasting water like that?
To show that even though one system has more air inside of it, their internal pressures will both be equal to atmospheric pressure, or at least very close to it. The relatively rigid containers prevent the pool
Deadpool is such a good
from
movie.
compressing or distorting the air, unlike the bubbles. So they rise according to the same accelerations due to the individual reactions of their respective buoyant forces. I hope you were taking notes.
Yo, is this gonna be on the test?
Is it?
Yeah, I hope you guys, like I said, you were supposed to take notes.
You're kidding me.
10 minutes later. Did you guys know that I was the one who said 10 minutes later? That was me.
Really?
Yeah.
I thought that was Dylan.
No, I was working on my French voice for a long time, and it really came together after a lot of episodes of SpongeBob.
Oh.
So what have you got there, Jethro? Looks like you found something.
Yeah, someone sent me a message, like across the pool.
Like in the pool? Like they didn't just tell you?
Yeah, good thing I could swim.
Where? What do you think the message is? Oh, hey.
Come on, why?
I mean, I guess they have school spirit.
Yeah,
What are we doing here? Oh,
swirling water.
spin it, yeah.
Spin it up.
Oh, we did use a lot of
Slow-mo.
slow-mo, didn't we?
So much.
That was a lot of slow-mo. But
Oh,
hey,
dang.
we have like, what, almost 5 minutes, right?
Yeah,
Just look at that drip.
That is pretty cool.
Yeah,
the
nice
reverse
drip
is
there.
better though.
I'll bring
yeah.
it back.
Everything looks better in reverse, especially with water. And especially spinning water. Everything's better with us, actually, I would say. Probably.
GCB.
What?
GCB are last letters. You don't get it?
I guess.